audience participation, some shows of hands going. The survey crew will hopefully appreciate that. The main focus of our talk is going to be on solid principles. So, just to give you a bit of background about me, give you some credibility or make sure that you don't think I'm an absolute idiot. For the past, I used to be head of development at 5x5, which is a reasonably large digital marketing agency in Southampton. I was there for about 8 years, and then about 3 years ago, I moved to a tech company in Eastleigh, not too far from here, and they're in the logistics and e-commerce industry. My first project there was building Com, which is a software as a service e-commerce platform, very much like Shopify. There's about 7,000 businesses from the UK and around the world running their e-commerce websites on that platform. It's quite a big kind of code base, huge application. As you can imagine, it's a really flexible kind of platform to allow all the different types of e-commerce web shops that people want. There's engines, all of that kind of stuff built in. The next thing I've been working on for the past probably 8 months or so is, I mentioned the company is in the logistics industry. It's called Parcel Monkey, and maybe about 2 months ago now, we launched our global marketplace for parcel delivery services. So the likes of TNT, DHL, DPD, Parcel Force, these couriers that you will hopefully have heard of. You can book their services on our platform, and we've launched in France, Germany, Belgium, Italy, Spain, and the Netherlands. And we've got US coming really soon, and then Australia, New Zealand, Hong Kong, and China, and India coming later this year. So that's, again, another quite big platform. So, moving swiftly on. So, what is solid? So, it's essentially these 5 principles. As you can see, single responsibility principle, open-closed principle, list-off substitution principle, interface segregation principle, and dependency inversion principle. Has anybody heard of solid before? Good. Okay, so they're not hard and fast rules that should always be applied blindly, but you do need to know them, I think, in order to help you make better, more informed decisions about when to apply them and when it's not okay not to apply them. Okay, so another quick show of hands, if that's okay. Hands up who's inherited a code base from another developer and they've looked at it and gone, what the heck is going on there? Yeah, like if somebody doesn't put their hands up, you've not been doing this long enough, because that's happened to everybody, I'm sure. Okay, also another one. Who's come back to some code they wrote 6 months ago and thought, what was I thinking? That doesn't make any sense, yeah? Okay, everybody again. Okay, then final one. Who's come back to some code 6 months later after they wrote it, had to make a change to it, deployed it, and introduced a bug when they've done it? Yeah, the ones that haven't got their hands up are lying. Definitely, everybody's done that. Okay, so why do we care about what solid is now? Why do we care about those 5 principles? Well, they're all designed, in summary, to help you write better software, but more specifically, they help you write maintainable software, understandable software, extendable software, testable, debuggable, reusable, and software that's a lot more robust and a lot less fragile. So, essentially what it means is it makes adding new features or changing code easier and less likely to introduce bugs. And it makes it easier for new developers that come onto maintain that piece of software It makes it easier for them to understand and to make changes. So what we're going to do is we're going to look at a simple piece of software using some PHP syntax that hopefully should be familiar to everybody for a shopping cart application. And then we're going to go through some hypothetical scenarios about how that code could evolve and change over its lifetime. And we're going to come up against some challenges or some potential issues that implementing those changes is going to cause. And that had we considered the solid principles while we were writing the code in the first place, that might help us to avoid those problems as we move on. So it's a simple application. It's a shopping cart, as I said. So we've got value objects for product, credit card. So we've got expiry year, expiry month, get last for, get token for a credit card. We've got a simple gateway class just to handle our payment processing. It's got a purchase method on there. And we've got a bit of a more complex, but a shop class that's going to handle all of our shops type stuff like the basket and the checkout functionality. So these set of classes, so whilst they meet our current requirements, you can hopefully visualize how they fit together. And so we've got a product, we've got a shop where we can add products into our basket, we've got a credit card, and we've got what do we have? A gateway where we can pass the credit card and the shop and the basket into the gateway and try and purchase something. So, whilst they meet the current requirements and they look simple enough, as I said earlier, they don't really consider the solid principles. So, as a result, in a real-world e-commerce store, where these classes would actually and obviously be much more complex, when those requirements change and we need to update these classes, we could introduce a lot of bugs. Or when a developer joins the project, they might be unsure how you originally intended new features to be added. And they might make changes that cause future requirements to be more difficult for you to implement. So let's take some possible new requirements, okay? Imagine this, you've deployed your e-commerce store, it's making loads of money, for your client, your manager comes in and says, oh, the client wants to add some new features. So let's say, as an example, they want to add or remove multiple quantities of a product to the basket at a time. Yeah, that's reasonable, isn't it? You're on a product page on a website, you want to buy this t-shirt, you want to buy 2 of them, and you don't want to have to press buy or add to cart twice. The user wants to be able to go, little drop down that says, I want 2 t-shirts, this basket, okay. Or maybe, they want to change the order confirmation email. Something like that. So every change comes with the possibility of introducing a bug. So the fewer responsibilities that a class has, the fewer reasons you might need to change the code in that class. And therefore, the less likely it is that you're going to introduce a bug. Also, smaller classes, they're easier to understand and maintain. And that's pretty much what the single responsibility states, the first of our 5 solid principles. So classes should only have one reason to change, and therefore should only have one responsibility. So, as I mentioned, we've got these 2 possible hypothetical new features to add, multiple quantities of a basket to be added at the same time, or change the order confirmation email that we're sending. So, thinking back to those 4 classes that I showed you earlier, did anybody have an idea about which of those smells like it might violate this principle? Any suggestions? Remember we have product, button?
Sure.
Shop. bang on. Absolutely. This bad boy. So we've got stuff to do with basket and stuff to do with checkout in here. And if we ever needed to change something to do with the basket, we could possibly introduce some other bugs to do with the checkout, or vice versa. So, what would we do? I think it's fairly obvious what we might do to help our original code abide by the single responsibility principle. We might split it out. So we might have two classes, and we'll put those red ones in the first class and the green ones in the second. There we go. So we might have a class called basket and a class called checkout. So what we've done is we've split those jobs. We've given the jobs of managing the basket and the jobs for handling the checkout. Because they're different, they've put them in their own classes. Basically, the fundamental thing, I guess, to remember is just don't mix the jobs. If you've got code that needs to perform multiple things, put it in a separate class. It's fine, it doesn't matter. So, okay, manager walks into your room again, says, okay, so client's got this new requirement now, and he needs you to ensure that the stock count of a product that's added to a basket is decremented when the customer checks out. Yeah? So you've got 10 t-shirts in stock. When somebody buys one, you need to make sure that the stock count goes to 9. Yeah? Simple. So this is our checkout method. So just to mention, all of the code for it is there's a GitHub repo, which I'll show, the URL I'll show at the end. So it's all fleshed out in there, and you can see, it's broken down into the stages that we're going to go through in the presentation, so you can have a look in there if you're interested afterwards. Okay, so we can't currently achieve this very easily without modifying our existing code. So our code doesn't make it easy for our future selves or a colleague to add this new decrement stock count functionality without making changes to our existing code. And as we said earlier, that could introduce a bug in our tested and released software. Yeah? So we want to try and avoid having to go through and retest everything else. Yes, you can have automated tests for it all, but maintaining them, if you've got a small project, can be a bit more of a pain than it can, than you can be bothered to deal with, but in the long run probably would be better. But okay, so how would you add this functionality without modifying this existing code? And you can make any assumptions that you like. Okay, so you can be in a MVC framework like Laravel or Cape or Slim or some Symfony framework or something like that. You could be calling this class and the checkout method on it from a controller. So maybe sure, we could extend this checkout class maybe, and we could override this checkout method, and then in it we could call parent checkout, and then we could check if the result was true, and then decrement the stock levels, for all the products in the basket. But what if we then need to add another feature again? Keeping with this principle of we don't want to edit or modify our existing code because that could introduce bugs. Or another developer might want to not edit the existing code of another one, but he might want to kind of add new features. But if we have to extend it, what if we have to add another new feature? Do we extend it again and again? Where's it going to end? Okay, or maybe we edit the checkout controller, like the controller in our MVC framework, that calls this method, and we test the results of it at that point, and then decrement the stock counts there. Okay, but what happens then if you've got lots of controller actions where you could be calling this checkout functionality. You know, you've got a controller action for credit card payments, you might have another one for handling the response from PayPal, or you might have you know, another one for handling the response if you accept Bitcoin or something like that. If we add it in all of these other places, we've got to repeat ourselves lots and lots of times, and that's going to obviously violate the don't repeat yourself principle. So, how do we go about doing that? So this kind of ties in with the next principle in Solid, which is called open-closed. So this states that objects and libraries should be open for extension but closed for modification. And that basically means it makes it easy to add new features or change the behavior without modifying the original. And then this last point is quite interesting. The purists that adopt this principle, they even say that you shouldn't even extend the original code. And it's like, well, okay, well, how can I modify the behavior if I can't change it or extend it or whatever, you know? That's crazy. How do I do that? Has anybody got any thoughts on how that happens? Yeah, absolutely. You build extension points into your original source code. You can fire events. You can have a plugin architecture. You could use composition. You can use a strategy pattern, or maybe add some callbacks in, or something like that. But this is cool because it means that you're defining the way that you want your code to be extended, which makes it reminds your future self, and it hints to other developers working on this project at a later point that if they need to extend this code, there are these points, there are these extension points within it that they can hook into to add additional functionality without modifying or extending the original code. Just a little bit more on that, if you want to take it even further, the purists advocate using final classes, which obviously completely prevents another developer from extending your base checkout class. Okay, private members, again. So, again, this encourages extension of features or addition of features in expected or supported ways. And it encourages decoupling between your code and what somebody else might extend to add another feature. And it reduces the risk of any changes that you make in your code in the future breaking the code that somebody else has written that extends your original code. The other way of thinking about it is that final and private, member variables and final classes, they can be changed. You can do anything you like with them without the risk of introducing breaking changes to your code that extends that, or other people's code that uses yours. And it removes the burden of refactoring. So you might need to change something. You might need to change an interface or something like that for a class. If you're change like an abstract class or something like that. If your members are private, then you haven't got to worry about them. You haven't got to worry about a class deep down in your code that you haven't even written, somebody else has written it, but they're using one of your member variables. If it was protected and you changed it and it didn't change in their code, then you'd be introducing a breaking change there and introducing a bug. And it's a hell of a lot easier to make a class not final or a member variable not private than it is to go the other way around. Yeah. So if you start private, then makes everything much more robust. Okay, so what we've done here is we've introduced this checkout event here that's going to get fired you know, after the basket's been purchased. And I'm going to show you in a second a decrement stock listener class that's going to listen to that event in our code. Okay, so had we fired this code, this event in the first place, then we'd have been able to add this decrement stock level listener into our code base without modifying any of our code. We've added this new feature, and all we've done is deployed a brand new class. We haven't changed anything. And all modern frameworks support events and listeners, so there's really no excuse not to just fire them, because who cares, you know? It's just another class that you have to write, but with editors these days, you know, creating simple kind of event classes like that, super easy, yeah? And, oh my god, how arrogant are we? We've made the class final as well. You heard that? You know, so some people say, God, how arrogant. How can any developer, you know, name their class final? How can they know that no other developer is going to need to extend that? But it's not the case. I mean, they do it to ensure that they don't introduce any breaking changes. They provide other extension points. There are alternative ways for people using that code to extend it. And if there isn't, then if you need to extend it, you need to extend somebody's code in some way, you just get in touch with them and say, hey, look, you've not provided an extension point to cater for this scenario. Can you either add it or not make your class final? You know? And like I say, going from final to not final, that's a hell of a lot easier than from going from not final to final, because that would introduce better breaking changes. So it's pretty controversial for some developers, but I don't think it needs to be at all. Okay, next one then. Manager comes in again. Client says, so I've got these great t-shirts, but they all come in one size. Oh no, and there's, you know, everybody comes in different sizes. You know? So we need to have small, medium, large. And yeah, I've got this great design, but it needs to come in like white, black patterns and stuff like this. So we need to introduce product variants. Yeah, that's every e-commerce shop that's got product variants, hasn't it? You know, different sizes of clothes or different colours or whatever. So, okay, well, you know, in our simple example, we could make each new variant, it could be its own product, yeah? But I guess like in a Ripple store, you'd probably want to have them as related, but like separate entities. So like a product entity might have many, you know, a one-to-many relationship between a product and product variant. So we could maybe have like the name and the description attached to the product, and then the variant we would have attributes, things like the sizes or the colours, for example. But each variant would have its own price, maybe, would have its own stock level, definitely. Okay, so how about we make this new class, this product variant class, we make it extend product, maybe. But then we could probably still add it to our existing basket. Maybe our existing, you know, this decrement stock listener might still work. So, no. In our order confirmation email, okay, we've got this piece of code there that explicitly calls get name on our product. But we needed to display the product variant. You know, if that's what was ordered, we needed to say, you know, it's this t-shirt but in small and black, for example. So, unfortunately, we can't just use our product variant subclass of our product class. Okay? You know, the behaviour of our application is it's not going to work the way we want it. So our application can't support swapping out a parent class for a subtype. And because of that, it violates the list-off substitution principle, the third in our in our principles that we're looking at this evening. So this one states that you should be able to swap dependencies for a subclass without causing unexpected results. So we can't do that. Our product variant extension of a product, although it makes sense to kind of make it an extension because it's still a product essentially. It breaks this principle. So really what this means is every single functional method which expects an object parameter of class A must be able to accept a subclass of A as well, without knowing it. The meaning of this principle is that every time you write a subclass, you have to make sure it's substitutable in every place where you use an instance of that original class. And the subclass must respect the contract of the superclass without changing the behavior in such a way that it would be impossible to recognize the new instance as belonging also to the superclass. I know that was a lot of words there, but hopefully the principle kind of makes sense. We couldn't subclass product variant, because although technically we could, it actually broke our application, or it didn't behave in a way that we intended it. Okay, so what we've done now is we've added a new method to our product class called getBasketTitle, and then we've overrode that in our new product variant class, which extends product, and it's going to tag on the size and the color details of our product variant. And then we've updated our send order confirmation email method to call this method on the basket item object instead of the getName method. Okay, in addition, we've introduced this purchasable interface class. So this imposes a contract on the objects that implement it. And that all of the clients, all of the classes that depend on this, they can rely on that object implementing this interface. On this class here as well. I know I didn't do it. So had we coded to an interface in the first place, and maybe had a bit of a think about this basket title requirement being potentially different from the name, we could have avoided having to have changed our tested and released code. Okay? So our send order confirmation email method, that depended on a very low level concrete class. There's another principle that we'll see in a second that says that you shouldn't depend on low level concrete classes. You should depend on high level abstractions, like abstract classes or interfaces. So had we done that from the start, we would have been able to add product variants to our application without ever having to change any code. Only add new code. Okay, so manager comes in again, okay? He says, I've spoken to the client. He now wants to sell digital products as well as t-shirts. He wants to sell MP3s or something like that, who knows? Audiobooks, maybe. Okay, so, well, maybe we can extend product again, right? So it's got to have a name, hasn't it? It's got to have a price. Okay, it also needs like a URL in there that you can download it from, maybe. Or maybe in the order confirmation email, maybe we ought to provide a download link or something like that. Okay. But we already extended product for product variants, so maybe we could do the same again. We could have digital product, extends product. New class, It makes sense to extend the product, it is a product still. New class, hopefully we can just add this code, add this class without having to change anything that we've already written, without having to risk introducing bugs. Okay, but oh no, just realised, we don't keep stock of digital products, do you? You don't have, I've only got 10 MP3s that you can download. No, you have one file, you can download it as many times as you like, or however many customers can download it as many times as they like. But we've got a get stock and a set stock, methods on our purchasable interface, which product implements, our product class implements this. So actually what we've done is we've violated the next principle that we're going to talk about, which is the interface segregation principle. Okay, so this one states, an interface should only impose the methods that a client relies on, and that we should split unrelated methods into separate interfaces. Okay, so let's have a look at what that might be. So, we've still got our purchasable interface, but we've got a new one, stockable interface, and we've split those get stock and set stock methods out, because they're not related, so they shouldn't be in the same interface. So if we've done this in the first place, then we could have added our new digital product, which extends product, into our application without changing anything, just by adding new code. New features added by adding new code, and that's it, not changing anything. This is a pretty powerful one. So, okay, coming up to one of the last ones now, this next requirement now then, and it comes in again. This happens all the time, doesn't it? And then you write some code, think, oh, it's brilliant, I'll never have to touch that again, I can forget about it. 1 week later, 2 weeks later, and then it comes in, oh, I've got a new requirement, it happens all the time. You're like, if only you'd have told me this in the first place, I would have coded it in a different way, and it would be much easier to do. Now it's going to take me 3 weeks. And your manager's like, what? That's ridiculous. Happens all the time. Okay, so he comes in again, new requirements, okay? He's laying them on thick this time. You've got to use a different payment gateway, okay? Well, you've got to support multiple payment gateways. So, SagePay or something like that for credit cards. You need a PayPal gateway for PayPal transactions. You've got another one for Bitcoin. You've got Stripe. You've got all of these other different payment gateways that you need to support, because they've each got great rates on this particular payment method. And then he says, while we're doing that, we're also going to accept loads of different payment methods. Apple Pay, Google, Android Pay, whatever it's called, Bitcoin, PayPal, credit cards, debit cards. All of it. I think there's like 150 different payment methods that are really, really common actually throughout the world, not just credit cards. PayPal, like what we used to. So, and then the other thing is, he wants to support things like subscription products. So he wants to be able to sell subscription pants or something like that. So you can subscribe to get new pants delivered every 3 months or something like that. So we need to be able to charge for things that aren't just like a customer basket. They need to be something that might be almost like a basket that's generated on a regular intervals or something like that. Or maybe a customer phones up and says, I only ordered one of these things, but actually I wanted 2. So you need to amend an order. It's not just a customer basket that this guy wants to be able to charge for anymore. Okay, but looking into our code, in our checkout class, and our gateway class, these ones they're depending on concrete classes. Okay, basket, gateway, credit card. So the code that we've got is very tightly coupled to these classes. Okay? And it makes it therefore difficult to add new features to support these new requirements without making lots of changes to our tested and released code. Which, obviously, that's the objective here, is to only add new features by adding new code, not having to change anything, therefore the risk of introducing bugs or anything like that. So, what we've done here inadvertently is we've violated the dependency inversion principle. Okay, so this one states that high-level abstractions should depend on low-level modules, and then both of them should depend on abstractions. Abstractions should not depend upon details, and details should depend upon abstractions. And we should depend upon abstractions, like abstracts or interfaces, rather than concretes. So, essentially, you can kind of distill all of that to the final point, which is code to an interface. So what that means is kind of represented by these three new interfaces that we've got here. So we've got chargeable interface, with a method on there, get chargeable amount. So that could be, basket implements chargeable interface, has a get chargeable amount on there for the basket value. A recurring kind of subscription product can implement that. Get chargeable amount could be the amount, the cost of that product at regular intervals. What else? An amended order. So implement get chargeable amount, which would, might be the difference between what the new order total would be minus the original order total. We've got a gateway interface with a charge method on there that accepts our chargeable interface rather than the basket that we've introduced in that one above, and also a payment method interface in there. And then we've got the payment method interface, and typically all of these kind of things, if you're normally normal level PCI compliant, I'm sure you guys have worked with payment gateways and stuff before. You might have like a token, for example, and then you might have a get details method on there to say, on like the order confirmation email, payment has been taken from, and then it might say like the last 4 digits of the credit card or something like that, or your PayPal account number or email address or something like that, if you're paying via PayPal, or last 4 if you're paying via credit card, for example. Okay, so we've introduced these three new interfaces to replace our basket, gateway, and credit. Well, not to replace, but to be used in place of, where we're defining dependencies, our basket, gateway, and credit card classes. As represented here. So, remember before? So, depending on concretes here, and now we're depending on abstractions. So by doing this, or had we implemented it in this way in the first place, we'd have been able to add all of those new features, subscription products, multiple payment methods, multiple payment gateways, without changing any of our tested and released code. Okay, so coming to an end now. So in conclusion, basically, what I'm trying to say is get classy. All we've actually done, if we look at if you have a look on the GitHub repo, and you take away all the new features that we added in the various stages of the process, just distill it back to those original requirements, all we've done, in order to be able to add all those new features, is introduce some interfaces and one event. So had we kind of thought about these principles as we were designing our software in the first place, had we coded to an interface, and had we thought about extension points, we could have started off still with a really simple code base. Not very many classes, not very many interfaces, not much code at all, but it met our requirements. But it was very, very extensible, very, very extendable to support adding loads and loads of new features. And it made it more obvious to other developers that might come and work on this project how they should extend the original software to add the new features that come about. So lots of classes, I think, that's fine. A lot of developers think, I don't want to add more and more classes because it makes it more complicated to understand, and it's just wasteful or whatever. I disagree. It makes it more maintainable, much more robust. And in summary, I guess, the big thing, if you take away one thing, it's about using interfaces as much as possible. Never kind of depend on a concrete class, always create an interface and depend on that. Does that make sense? Okay, that's it guys. I hope it's useful. So, any questions? Please feel free to shout out. Yes?
So one of the main barriers to using final on classes is how much more significantly difficult it makes it to mock those classes for using tests for dependent things. What would be a suggestion to get around that?
So,
I think prophecy uses some internal magic.
Yeah, like reflection or something like that. The frameworks not support.
As far as I know, it's the only tool that does it, and the way it does it is by calling some functions that affect the PHP internals to actually change the definition of the class before respecting it. But PHP units, Mocha doesn't do it out of the box. So if it starts having final on stuff, you'll pretty soon find that your code base becomes untestable. So within your earlier packages.
That is a good point. I'm going to do a bit of research around that and take your Twitter handle, and maybe we'll continue that conversation offline. That'd be good. That's a good point. Anybody else got any other questions?
One more.
Yeah, okay. Is it as difficult as the last one?
I hope not.
So, wait.
Your part of your event throwing is actually kind of violating dependency injection on that class, because you're not actually...
Sorry, can you say that again?
When you were dispatching an event from your class, you're violating dependency injection on your class, because actually there's an event manager that's passed into it.
You're absolutely right, yeah. So, the disclaimer around the code is that it is there to illustrate the principles as opposed to fully abide by version control principles and things like that that would otherwise overcomplicate the examples.
I've seen a lot of event systems within frameworks before, but I've always found them less useful than simply making your domain model return messages appropriate to the actions that are actually taken. So the invoking code can have some understanding of the actions taking place, can act upon that. That's usually a lot more useful to pull that all the way back to the executing.
Like a command bus type
Yeah,
architecture.
exactly. To be able to do those sorts of things than to try and dispatch something halfway through execution.
Yeah.
And kind of break the execution flow.
Yeah.
So I always advocated that to my events as a much better way of exemplifying those kind of internal values.
I do agree completely with that. Yeah, I use command bus architecture and domain-driven design principles in a lot of code that I write for those reasons. And again, this was kind of a way of illustrating the opportunities or the principle of creating extension points in your code without having to go into command bus architectures. Any other questions that aren't as hard as either of those two? Does anybody else have anything to ask? No.
Yes.
Yes, go.
So when your manager comes to ask you all these different things, don't you have a discussion and say, well, we might need to do this as well, rather than wait for them to come through, etc.
Absolutely, yeah, of course, in the real world, yeah, but still, there has been countless occasions where, with the best will in the world, we haven't been able to anticipate client requirements. I'm sure, you've had those scenarios as well. But yeah, you always try and, there's a point where you don't want to optimize too early, or you don't want to, build something that is more capable than it needs to be. Because more capability inevitably means more complexity, doesn't it? And unnecessary kind of capability and unnecessary complexity has an adverse effect on maintainability and understandability of your code. So you want to try and make your code capable of achieving that additional functionality that you can anticipate without having to actually kind of implement it. And that's really what it's all about. It's exactly kind of what I've been trying to say, I think, is designing your code to make it more extendable without actually having to implement all of those features. Yeah? So using the solid principles, I think, helps you achieve that. So that's your question. Okay. So I just wanted to say one last thing. So the company I work for, ParcelMonkey, we're recruiting at the moment. We've got loads of projects that we need to implement. We've got funding, additional funding, so it's a £10 million a year business at the moment. We're going on Crookes very shortly to inject a whole bunch of capital to increase our development team significantly and do a lot of marketing for our new global platform. You get good salaries, it's a good laugh. We've got some great problems to solve, really interesting projects. Those are things we want to be. If you're interested, grab me afterwards, give me a tweet or email me. I'm neil.crooks@parcelmonkey.com if you wanted to send me an email. So I'll tweet a link to the slides and the GitHub repo if anybody's interested. I'll start with But that's all from me, so thank you very much indeed for listening.